Hey guys, today we're going to be going over Charles Law Lab. And Charles Law Lab falls into our gas law unit. Now, when we talk about gas laws, you're going to remember there are four variables that we talk about with gas laws. We're talking about volume, temperature, pressure, and moles. And Charles Law specifically deals with the relationship between volume and temperature. This lab is going to deal specifically with how we change the temperature and that affects volume. Now, in the lab you had a worksheet that looked like this, and it took you through this lab step by step by step. But since I have you here, I'm going to go through it a lot quicker. Now, to conduct this lab, you're going to need a few pieces of equipment. The first thing you're going to need is you're going to need a hot plate. You're going to need a 1,000 milliliter beaker. You're going to need a 10 milliliter graduated cylinder. You're going to need a thermometer, and you're going to need a glass stir rod. The first thing you're going to do is you're going to get a handful of ice and you're going to put it in your 1,000 milliliter beaker, and then go ahead and fill it up with water until it gets to about the 900 milliliter mark. Take your graduated cylinder and fill it up to about 8 milliliters of water. Now the tricky part is you got to take your finger, cover the graduated cylinder so no water can leak around it, and you're going to go ahead and turn that upside down and put it in the water in the beaker. You can't let any water leak out until the tip of the graduated cylinder is all the way underwater. Once you do that, your air will be held within the graduated cylinder and you can go ahead and put it on the bottom. You should look something like this. Now, if you look at this closely, you'll see that you have a nice air bubble right here in the graduated cylinder, and you can look at this line to read what the volume of gas is there. Now, go ahead and put that on your hot plate. And what you need to do is you need to look at your thermometer, see what the temperature is, and look at your graduated cylinder and see what the volume of gas is. Once you've done that, you can go ahead and turn on your hot plate. You're going to use your glass rod to stir the water. You may have to put another finger on the graduated cylinder just so you don't knock it over or damage it or anything like that, letting gas escape. But you're going to continue to stir throughout this whole procedure. Watch your thermometer, and every time you increase 5 degrees, you're going to take another reading of your graduated cylinder. You're going to let it increase another 5 degrees, and you're going to take a reading on your graduated cylinder. You're going to do this until you have 5 recordings. Once you do, you're going to create a table that looks something like this. Now, here's your temperature in degrees Celsius. That's what your thermometer is marked in. And you're going to record the volume of air from your graduated cylinders right here. Now, one thing that makes it a little bit harder is Celsius is nice, it's what we use routinely, but for the gas laws to work, it always has to be converted to degrees Kelvin. If you don't convert it to degrees Kelvin, none of the gas laws will work. So for this entire unit, get used to this. Now, it's really simple to do. All you're going to do is take whatever the degrees Celsius is, and you're going to add 273 to it. And that's going to equal your degrees Kelvin. So let me show you one. Here I have 4 degrees Celsius. I'm going to add my 273, and that is going to equal 277 degrees Kelvin. Good. Now, I've went ahead and done that for you and filled in the rest of your chart. So this is what it should look like. Now, the next thing that we want to look at is we want to compare those two different variables. So I want to look at my temperature, I want to look at my volume of air. Now, as I look at it and I go down, I see as temperature increases, my volume of air increases. Good. We're going to call that a direct relationship. When they do the same thing with each other, that's direct. Now, if the temperature increased and my volume decreased, that would be inverse. But again, here we have a direct relationship. Now sometimes you'll draw this in a chart and it'll look something like this. A direct relationship should have this nice straight line running right here between the two variables. Another thing we can do is we can write an equation for any direct relationship to help us solve it. And for this particular equation, what we're going to do is we're going to take the number of milliliters and we're going to divide it by the degrees Kelvin. And if we do that, we're going to get a constant. Okay, so this constant will help us solve any problem from this point forward. So let's take a look. I've done a couple for us. Here we have 4.7 milliliters, which is right here, divided by 282 degrees Kelvin, and that equals 0.017 milliliters per degree Kelvin. I did another one down here, 4.9 milliliters divided by 292 degrees Kelvin, and once again that equaled 0.017 milliliters per degree Kelvin. Okay, so we see that this is a constant number. Now, it doesn't always work out quite that clean. You have environmental conditions which can affect it. Sometimes your recording instruments aren't quite accurate enough. So a lot of times you'll find several points of data and just average them. In this case, it worked out pretty clean for us. Now, once we find this constant, what can we use it for? Well, we took a very limited range of data. Right? We only collected temperatures from 4 degrees Celsius to 24 degrees Celsius, and we had a very limited volume of air as well. But once we establish this constant, we can use it to solve problems which are well without or outside of the range of data we collected. Here is a couple examples. You may be asked at some point, what would the volume of gas be if you increase the temperature to 330 degrees Kelvin? Well, this is above what we did, but we can use it by applying our constant. So here we go. We always start by writing down what we're given, 330 degrees Kelvin. And remember, this is nothing but a conversion factor. So I've got 0.017 milliliters over 1 degree Kelvin. And I could reverse that if I wanted to, since they're equal to each other. But I'm trying to get rid of degrees Kelvin, so I want that at the bottom, so I'm going to use it just as it's written. So here we go, 0.017 milliliters for every 1 degree Kelvin. And once I write that out, degree Kelvin cancels, I'm left with milliliters, which is what I want. I multiply everything on the top, and I'm going to get 5.61 milliliters. Now, I can also use that equation to find out what temperature I would have to get it to get 4.2 milliliters. So, again, I always start by writing down what I'm given, 4.2 milliliters. I'm going to make my little railroad tracks here. And I'm going to use this equation, but this time I need milliliters on the bottom so that they'll cancel out. So I'm actually going to flip-flop it. So here we go, 0.017 milliliters is equal to 1 degree Kelvin, and since this is on the bottom, I'm going to divide by that, and that's going to give me 247.1 degrees Kelvin. There's my units right there. So we can take that information that you collected, that data you collected, create the constant, and then we can use that constant to get information well outside the realm of what we tested. So there you have it, guys. That's the gas laws. I hope you enjoyed this video. I hope it helps you, and good luck with your studies. Thank you very much.